Hello, my name is James Scott, and today I'd like to discuss the design and development processes employed during the creation of app prototypes for the multi-platform UX design ICA. Armed with an idea for the app, the initial research began with a survey that was completed by peers. This focused on the app idea and features that could be included. This provided insight into how different people thought about product usage, maintenance and repair, and resulted in additional features that had not initially been considered. Research then proceeded on to looking at apps that used image recognition for a specific purpose, not just providing results from a search engine such as Google Goggles. The first of these was Garden Answers, which can be used to identify plants and flowers and then provide advice on their care and how to deal with bugs and pests. You can also have questions answered by experts. Another app found was ArtBit, which can identify artworks and offers information on the artist and any other works. It also offers a map service that will show where artworks are being found by other users in the nearby area. Further time was spent researching websites that provide user manuals and repair guides for various products. This included Manuals Online, Safe Manuals, and Retrievo, each of these offering hundreds of thousands of manuals available to view online or download. Another, eSpares, which primarily is a parts store, offers manuals and a comprehensive advice section covering multiple topics on various products. One thing I noticed, however, is that amongst these various services, none of them seem to provide an app to support the websites. That is until I came across iFixit, a service that provides visual guides to assist with the manual repair of almost 6,000 products. There are over 82,000 repair guides on offer, as well as a parts and tools store and community questions and answers forums. Unlike the other services, iFixit also provides an app which offers all the same features as the website and is available on both Android and Windows platforms. Initial research into target audience looked at consumer reports from Deloitte, CCS Insight, StarTech, and the Nielsen Company. When considering whether the audience persona should be male or female, Consumer Reports provided the answer. CCS Insight's research in 2013 found that interest in smartwatches was around 18% in males and 15% in female respondents. It also found that 30% of male respondents had actually researched smartwatches, whereas only 21% of females had done the same. Similar results came from StarTech's findings, released in 2015, which show that 43% of male respondents had expressed an interest in smartwatches. However, 68% of female respondents were more keen on fitness devices. Finally, the Nielsen Company's report from 2013 revealed that smartphone adoption was at 67% for men and only 54% for females. From reviewing these findings, the decision was made for the primary target audience persona to be male. Taking another look at the Nielsen Company's report from 2013, the highest adoption rate for smartphones is that from those of age 25 to 34. In addition to this, CCS Insight shows that interest levels in wearable technology is much higher for 16 to 24-year-olds. However, it also went on to say that younger people are more interested in technology and novelty and show very high levels of awareness. The CCS Insight report also shows that those aged 25 and above have awareness levels in smartwatches of around 60%, however those younger had much greater awareness in the technology. Another report, this time from Deloitte in 2015, found that 92% of those under 44 owned a smartphone, and of those, 40% of 16 to 24-year-olds say they couldn't live without a device. Based on the research findings, it was decided that the age of the target audience would be between 20 and 30, and using the midpoint from this, give an age of 25 years old for the persona. With the idea that the persona would be around 25 years old, and as such would be born in 1991, it was found by checking various websites such as weddingvendors.com that Michael was the most popular name for that year. According to their report in 2016, the Office for National Statistics found that the most common sector for employment within the UK was that of the construction industry. This was followed by professional, scientific and technical roles. Considering the fact that the persona would have high interest levels in technology and being able to afford the latest gadgets such as smartwatches, tablets and smartphones, it was decided that a role in IT would provide suitable income while still being a common role within the workplace. For a specific role within the IT industry, an article by Nicole Tripp posted on top10reviews.com highlights the roles most sought after by IT professionals. In this case, software engineer was indicated as the best role, and this provides a career path for our persona. Whilst most of the persona was able to be created based on research findings, there are still many unknown aspects. This means that only a provisional persona could be created for this assignment. Michael is 25. He works full-time as a software engineer for an IT company in the city. Each morning he commutes to work by train, and during his journey he likes to check his social media and read up on the latest technology news and developments on his tablet. Whilst Michael likes to have the latest technology and has just bought himself a smartwatch, he hates throwing away faulty equipment. And because he has an analytical mind, he likes to fix things himself. He usually finds advice online to help him fix these gadgets, but he would like an app that would help him access the information faster. Whilst researching delivery platforms for prototypes, two specific services stood out by offering not only free but professional and easy to use products. These were Marvel and Envision. And whilst both had similar features, Envision seemed to be the superior package with regards to overall features and usability. Envision caters for various import methods including direct file upload and synchronization with cloud applications such as Dropbox or Google Drive, meaning in-project files will be updated whenever a replacement file has been added to the cloud. Envision also provides the option of uploading various file types including JPEG, PNG and GIF. It also allows for the upload of Adobe Photoshop or Apple Sketch files. Whilst being able to use Photoshop files would be convenient, the decision was made to export all prototype screens in a compressed file format. PNG format was chosen because it would allow for reduced load times while still keeping the images high quality with this lossless file format. An alternative to this would have been to export in a lossy format such as JPEG, however this would have resulted in low quality images for use in the prototypes. The initial idea of the app was very different to that of the final product. This focused on allergies and an app that could be used to take a photo of a product or scan the barcode and then advise whether it had any ingredients that a family member would be allergic to. However, when discussing this with peers, I found that another student had a very similar idea, with their subject being focused on allergies. Because of this, along with the requirement that the app idea should be unique, a new idea had to be found, and this came from a short brainstorming session with family and friends. During the session, a brief comment from a family member stating they could never find the product manual gave birth to a new idea. And this is the point where I began the initial research that I've discussed previously. The first stage in the design process was to think about the layout, fonts, and colours that would be used, which meant further research was needed into the various platforms on which the apps would be delivered. This included Apple, Android, and Microsoft Windows, looking specifically at the design around the guidelines for creating applications for these platforms. With regards to smartwatches, it became very clear that text input methods are limited, and whilst various solutions are in development, such as the Touch One keyboard for Android, changes in the core software would be required to allow this to work outside of a single applications. Apple Watch currently offers previously used phrases from conversations or user-created sets with the support of an iPhone app. Alternatively, dictation can be used via Siri. Apple has very clear guidelines for the development of Apple Watch apps, and this provides a rule set for using the theme, layout, and interaction styles of any new applications. Because of the challenge offered by Apple's guidelines, a decision was made to use this platform specifically for the smartwatch prototype. Smartphones offer a much larger screen size, include keyboard input, and almost every smartphone on the market includes a high quality camera. I believe that smartphones would offer the quickest and easiest method of interacting with an app that uses image recognition. Also, since the smartwatch prototype was based on an Apple product, Android was chosen as the platform for the smartphone. Whilst researching design guidelines for the Android website, there doesn't seem to be as many limitations on the actual design of the apps. It almost seems as if Google are telling developers to go wild, create beautiful and fully interactive apps, not just buttons and menus. When it comes to a desktop solution, the greatest screen real estate will be on offer, and text entry using a keyboard will be simple and straightforward. For image recognition, a webcam can be used, or images could be uploaded from various sources. However, when it comes to desktop applications, there's many platforms for delivery, such as Apple iOS, Windows, Chrome OS, and numerous Linux products. Because it would be rather time consuming and less cost effective to create tailored applications for each platform, the decision was made to focus on a web application for the desktop solution. The clear advantage of using a web application is that it will allow access to all of the features via any web browser, and only minor coding adjustments would be required to ensure cross-browser compatibility. With this in mind, current trends in web design were researched, and UXPin provided some fantastic insight into the latest trends being used by developers and designers. In addition, articles by Carol Francis and Amber Lee Turner gave further speculation on upcoming trends, some of which were adapted for use in the web application. During the various stages of research, ideas for the user interface, colour and theme were considered, and a mood board was developed with each platform in mind. Rough sketches were drawn up for each of these platforms, wireframes were done based on these, and then the final prototypes were created. These incorporated the layout from the wireframes, design aspects from the mood board, and some redrawn elements from the sketches. The product name and logo were thought up during the initial sketching stage by thinking about everything the app would do, with the idea that this is an identification app that provides help and support to the user while they're working on a repair of products. Taking the first four characters from identification and adding in the internationally recognized medical cross symbol, a logo was created. In addition, because the logo may look like ident when handwritten, a way of pronouncing the product name was obtained. Throughout the design process, both verbal and written feedback was obtained from peers where possible, as well as additional feedback from family and friends when this was unavailable. The first piece of documented feedback I mentioned previously, which was focused on application features. The second was a three-part feedback form focusing on the design and usability of each prototype, as well as requesting suggestions on how the applications could be improved. One particular suggestion was to add App Store links on the desktop application. Some mentioned how the background effect on the phone created too much clutter, making the text harder to read. Whilst not all of the suggestions were used in the prototypes, it is felt that there may be room to include these in a final release product. There was also some extremely valuable feedback from one respondent that could be used in the future product designs. Today we've reviewed the research completed with regards to various products, competitors and platforms, as well as that used for the creation of a provisional persona for our target audience. We've also discussed the various file formats, compression and delivery platforms. We've looked at the design journey from early ideas along with the mood board and initial sketches all the way through to the final prototype design. Finally, we discussed the methods of feedback and evaluation used during this whole process. I'd like to thank you very much for your time spent watching this presentation. Please do enjoy the rest of your day.